Once again, thank you for the introduction. My name is Branislav Djordjevic, and I come from the Innovation Center of the Faculty of Mechanical Engineering in Belgrade, and I will show you a comparison of two recent approaches to ductile to brittle characterization of ferritic steel developed by our institution. Some of this team, some people are also involved in this research and are not listed here. I will be short and concise as much as possible. So, sorry. Beside the presentation of the basics of these two developed studies approaches, I will show you the demonstration of application of these two methods using the Eurofracture data set of this ferritic steel, as you can see on the screen, in the function of the stress intensity factor in the index of JC at the temperature, and the data set results at the -60 degrees. As you can see, this is the ongoing research, and this is the paper that need to be that is a part of this research. So let's start with the first one-point method. As you can see, it uses Weibull statistic and is based on the Volin research. Since I have a limited time, I will not go deeper into the problem and the basis of the Volin research. As you can see, based on the smaller CT specimen size, we predict the behavior of the larger CT specimen size. And this method is an economic one because it uses only one pair of data set that is used for the prediction, the behavior of the larger CT specimen size. As you can see, it uses a regression analysis, and one of the Weibull parameter beta is size independent and is fixed. So let's switch to the second two-step scaling approach. As you can see, it is based on the two steps scaling as illustrated on the figure on your right side. And the two premises are shown here, equation 1 or 2. In this approach, we imposed a shape function based on which determine the beta and dependence of beta and shape function is sigmoid, and I don't have a time to explain this, maybe later. So let's switch to the demonstration of application of first method. As you can see, the method, the demonstration, the application starts with the fitting of the experimental results of the smaller CT specimen size. In this case, we CT 25. Based on these results, we did a prediction, estimation of the prediction, estimate of the behavior of the probability of failure of larger specimen size using this equation. You can see the parameter of Weibull CDF. Here you can see the CDFs of the probability of larger CT specimen size. As you can see, this method is more, how to say, a rigid one and a conservative one. For example, for KJC of 100, the probability of failure is much larger than the experimental results, and this feature is pronounced with the increasing CT specimen size. So let's switch to the second approach. It uses two pair of data set. We need two pair of data set to predict larger CT, the behavior of larger CT specimen size. This method starts with a fitting of experimental results. Here you can see available parameters. Then we did, this is the mathematics for the prediction. For the prediction in this case of CT 100. Then we determine the beta. In comparison to the first model, beta was fixed. Here, this is not the case. So this is the variable parameter for the larger CT specimen size, in this case for CT 100. As you can see, this prediction is more realistic. It's not so rigid, and in comparison to the first one. So to conclude, I think you saw the two methods, approaches for the prediction of fracture toughness. First approach is more rigid, and from the point of the structural integrity standpoint, it is more safer, but is expensive. It's not economic one in comparison to the second one, which provides more optimizing feature in designing of the structure based on these results. And further direction of this study will goes in the how to say, in the study of sensitivity of the size of the data set, based on which we will predict larger structure. So this is it. Any question?